In this scene, we'll be creating a custom splash from our number 6. We'll use xpFluidFX and xpSheeter, and then we'll look at meshing this with the OpenVDB mesher. So, let's get started. So here we are in our 5 shrink scene, and what we need to do is borrow some elements from this so we can do our 6 splash. So what do we need? We need our plastic bag animation, and we need one of our mode text objects. Doesn't matter which, we'll be turning it into a number 6. So first of all, we need our plastic bag. Let's just bring in the subdivision surface. But when you're copying in an object that's been cached, you need to copy in the parent cache object too. So just before we do that, let's just rename this one, so we're going to remain organized, because in our new scene, we'll be bringing in another cache object eventually to cache the new particles, and so we don't want to get mixed up between the two. So let's just rename this now, and we'll call it cache, and then just plastic bag, and we know very easily now which one it is. Great, so we'll take this, and we'll highlight the cache object, and we'll take in our number 5. And just before we do, also if you're copying an object with a cache tag, let's just go into the tag. Always make sure you've got copy tag data selected. And that means that when you paste this into your new scene, let's hit Control C, it'll all be hooked up automatically and you won't have to kind of reconnect any folders. So let's go to File, New, and Control V. And there we go. Look, we've got all of our stuff pasted in with our nice keyframed animation. Everything's looking very good. Right, so what are we doing? We are creating, this is the transition from our 6 fill into the 6 splashing out and creating this plastic bag. So for now, what I want to do is we don't want any animation on our plastic bag. So let's just go to our cache tag. And instead of play per frame, let's just uncheck that and let's put the scale on 0. And now what's going to happen is the bag is just going to stay, it's going to be static on that, on the first frame. Let's put our timeline up to say 200 frames. Okay, good. And we could, let's just make this invisible for now. So now we've got our mode text. We actually want this, remember, we want this to be a 6, because this is going to be in exactly the same position as when our 6 fill finished doing its thing. And then we need this to turn into a blast of water splash particles. So now we have a number 6, that's looking good. And we can also actually hide this now. Let's change the name of that now that we've changed it from a 5 to a 6. Let's call it our 6, just so we don't have anything that's named confusingly. Right, so at this stage, we could bring in a new xParticles system. So let's go to xParticles system. And I'm actually going to leave these elements outside of that system because I don't want to get confused. I want to know that this system contains all of the new objects that I've been working on in this scene, and everything else is outside of that. And we can reorganize as we go, but for now I'm going to keep them separate. Good. So in our system, let's just go to the object. Let's deselect icon in viewport. We can use this default emitter, but we're not going to have it in this default square emission mode. Let's go to object, emitter shape, and put it on object, and our object is going to be our number 6 geo. Okay, very nice. So now let's make that number 6 invisible, and let's rename this emitter as we go. Let's stay organized, so let's call it emitter water, and in the display tab of the emitter, let's change it from green to blue. Just like to have a blue color for water when I'm working in the viewport, and we could change the icon color as well while we're at it. Okay, so now we have got, oh actually look, let's it's behaving oddly. Look, we've got these particles emitting, and they're kind of, some of them are sticking, some of them are falling around the place. It's all looking a bit weird, and that's because our number 6, when we brought it in, remember, we had a collider tag on here. Now we have this as a collision object, so because we've got self collisions active, it means that the particles that are being birthed from this object are also colliding with it, which is causing us problems. So we can actually just deactivate. In fact, we don't even need any collider tag on this. Let's just get rid. We just want to use this as an emission. So now we can see it's kind of emitting out from this number 6, and it's not hitting anything. So let's set up that. Our plastic bag, we want to catch particles on the inside of it. So this needs a collider tag. Let's go to Tags, xParticles Tags, and Collider, and we want this to be on the inside. And now we're starting to get particles interacting and staying within the volume of our bag. So we can immediately see what's happening here. This is looking right. Now, can you notice that, look, we aren't filling up the corners of our bag? And that is because, remember, our particles have a size which we're not seeing here. We're just looking at the central dot. But they have a radius of, it'll be the default 3. So let's just put that down to 1.5. So the particles are too big to be able to fit in these corners. We stick it to 1.5. You're going to see that, yeah, they're getting much closer. Now, they're not perfectly in there, but they are going to be close enough. Okay, so now we're at this point. Before we move on, let's just get saved up, and then we'll kind of be organised. We'll have our structure, we'll have a save point, and we'll be ready to move forward for the more complex stuff. So let's go to File, and we'll go Save As. And what we want to do is go to MoGraph Countdown, and we will go to New Folder. Let's call it XP Countdown. So it's a number 6 again, number 6, and let's call it Splash. And I'll copy that name. Let's go into that new folder. We will call the file the same name. Let's give it that version number as well. Okay, good. And just before we save, let's do a new folder. Let's call it Cache. All right, and then we'll hit save. And there we go. Right, so now we're ready and we're organised and this scene is okay. So now we can start looking at this splash. Now at the moment, this emitter is set to be a rate emitter. It's in emission mode rate, which means it's firing off 1,000 particles per second. We don't want that, we just want one splash of particles. So to do that, let's change it from rate to shot. And now we've just got one blast. There we go, and we could increase this particle count. Let's maybe put it up to 2,000. There we go. So there's a splash of particles, and all they're doing is rebounding off this. Let's just actually take away that bounce and put a bit of friction on there. So we need to, for these particles to behave in a more kind of fluid-like way. So what we'll do with that is let's go to Dynamics, and we'll go to FluidFX, and we'll bring in our FluidFX. So now they're behaving more fluid-like, but we haven't got any gravity in our scene. We haven't got any forces moving them around. So at the moment, they're just kind of blobbing out. Some of them are kind of joining together, and they're behaving more like fluid, but it's not quite right. So obviously we need way more particles. But here's the problem. If we just use FluidFX, and then let's increase our particle count by 10, 20,000 particles now, we get more of a splash, and it looks okay, but we're not really getting any nice kind of tendrils, any kind of crown splashy tendril type shapes, and that would be really nice. So instead of doing it like this, let's reduce that shot count back down to 2,000. And what we're going to do is, instead of using FluidFX with loads more particles, we'll still have FluidFX, but we're going to use an xpSheeter to create a more interesting splash shape. So let's do that. We'll go to Dynamics, and we'll go to the Dynamic Objects and bring in an xpSheeter. So let's just play this on default settings and see what happens. So what xpSheeter does is it takes two fluid particles, and if the way in which they are behaving satisfies the settings that we put here, it spawns new particles in the gaps. And it's really, really clever object. And you can see actually it is working ever so slightly. We're starting to get some new particles spawned in here. If I switch that sheeter off, you see, look, this area here is very sparse. Switch the sheeter back on, and look, it has filled in somewhat. So what is it doing? Well, first of all, at the moment, it is only sheeting particles that have a fluid density of between 0 and 5% of that maximum fluid density range. So most of these particles aren't being considered for sheeting. It's also only sheeting particles if the hole is 20 centimeters or below. It's only sheeting particles if they are under 400 centimeters with max speed. And this velocity alignment is a really interesting one. It's only sheeting particles if they're moving away from each other at an angle of 30 degrees or less. So at the moment, these settings are too restrictive for it to birth too many new particles. So if I just start increasing this max density, it's going to start allowing more and more particles in this kind of sheeting equation. And you can see we've got loads more being filled in. And if we then, look, reduce this angle size, we should be able to get some more kind of tendril-looking particles. All right. So I think what we could do with, before we start making any more adjustments with the sheeter, it feels like we're a little bit too slow with this explosion. So let's go to our emitter water and let's increase the speed up to, well, let's try double the speed, 300 speed. There we go. That's looking more splash-like already, isn't it? And you can see, look, we're getting these really nice kind of sheeted tendrils. So let's just go back to our sheeter and see if we can make a few more adjustments. Let's just try reducing that max hole size. So you see, now we're getting some really thin tendrils, but then it can't fill any of these larger holes, and we start having a very kind of sparse volume. What we want is a nice thin sheet over the entire inside of the bag. So let's put that max hole size back up to 20, because that was working okay. And let's just reduce that max density a little. Okay, so that's looking nice. So I like the initial splash, but then we need to start filling this up more significantly. At this point, look, it's just way too sparse. So I'm going to increase our max density to include more particles across the board. That's a nice splash. I really like these tendrils here, these holes. So at this point, we want it to now start filling up more quickly. So what we could do is, well, a couple of things. We could make some keyframes here. So let's just play that through again. At this point, let's put a keyframe on our angle, which is quite a small angle, this. And let's put that way up to, say, 50. So now, loads more particles will be viable for sheeting because we've increased that angle. And look how much more quickly they're being spawned. So what we could also do, I think, at that point, so we fill this up more quickly here, is keyframe our max hole size. Let's go forward and keyframe that up again a bit higher, which is going to include loads more particles for sheeting, and fill in some of those bigger holes. So look, we're getting a really, really massive amount of particles very quickly. Now you can see we're getting slowed down performance in our timeline, and that's because if you think about it, the sheeter is doing an awful lot of calculations here because it sheets the new particles, and so it may double, triple, or even quadruple the amount of fluid particles that you have. But then all of those new particles are then being calculated for sheeting as well on the next frame, and so it really can get heavy quickly. So this is where you need to be careful. But we're almost at the point where we've filled our volume here. So once we have filled it, we can actually switch that sheeting off and then just let FluidFX do its thing. So let's just keep going forward a few more frames, maybe one or two, until we have got all of these holes filled. A couple more maybe. One more after this. Okay, press stop there. Let it finish its frame that it's on. And there we go. So, and then look, the majority of our volume is filled here with our particles. So that is going to do us. That's what we need. We need to get to this stage. So at this point, let's go to my basic tab of my sheeter. Let's hit a keyframe on enabled, go forward 1 frame. It'll just take a while to calculate because obviously it's birthing more particles. There we are. And then let's disable it. So what will happen is it'll gradually get heavier and heavier and heavier as it's making more and more and more of these new sheeter particles, to the point where it really slows down because we're getting so many per frame. But these kind of holes filling in are going to give us some really nice detail when we come to mesh this. So this is looking really good already. So here we go. So it's going to chug a little bit now from here to our last keyframe, the next 4 or 5 frames, because it's making so many calculations for us. It's slowing down and working through those, but we're getting there. And as soon as we get past the keyframe where we've switched off our sheeter, the FluidFX will then start solving much more quickly than this. And there we go, look. So now FluidFX is just doing its usual solve, and that's working well. Now, one issue is that we've got these holes developing in our mesh, which could, on paper, cause some problems. But actually, what we'll be able to do is make some adjustments when it comes to the meshing of this to make sure that these holes aren't going to harm us. So that's looking really, really good. I am very pleased with this sim. That's looking excellent. Okay. So there's actually one thing I want to show you. We don't have, we have our FluidFX settings on the default settings, which are the accuracy, the fast preset, which are the fastest settings, but it means obviously it's not the most accurate of simulations. For this, it's working fine. But I just want to show you a scenario and how to fix it should this accuracy setting not be good enough, and how you would know it was not good enough. So let's just go to our emitter. And I'm pretty happy with these settings, so we are going to keep it at this. But let's just increase our speed to, say, 400. So these are going to be blasting out much more quickly. And let's just have a look, see what happens. Now, here we go. So can you see, we've increased our speed. Can you see that we have some particles which have leaked? They have managed to get out of our collision object. So why has that happened? Well, that is because these particles are moving much more quickly. And at that speed, FluidFX, under the fast accuracy preset, doesn't have enough accuracy to be able to solve for particles that quick. So what is happening under the hood is this. These accuracy presets automatically set the minimum steps and maximum steps per frame, and the steps are what FluidFX uses to solve the velocity of the particles, the movement of the particles. And it also, under the hood, sets the min and max iterations per step. And the iterations is what FluidFX uses to solve the fluid density. And so on fast, we don't have very high max steps and max iterations. And in this instance, on fast, there are not enough FluidFX steps per frame to accurately solve the velocity of these particles, and as a result they have leaked. So if I change this just to another preset of medium, which is going to be giving us more maximum substeps, so more velocity accuracy, if we hit play, that is enough to accurately solve the velocity of those particles so they are no longer leaking. So if you have a FluidFX sim with a collider object and you can't understand why particles are leaking, that is going to be the reason. There isn't enough maximum steps per frame to accurately solve the velocity of those particles because their initial speed is so fast. So up your accuracy with the presets to the higher ones until you get a sim that isn't leaking in that way. But ours was working on fast. Let's go to the emitter, put it back down to 300. So 300 was fine. And there we have it filling up. Excellent. So what I'm going to do is, now that we've got this and it's looking nice, this is kind of the first stage of our kind of splash forming into our shrink wrap bag. So what we could do at this stage is start thinking about setting up a cache. So let's do that. What we'll do is we'll just cache maybe the first 60, 70 frames, play it back to see how it feels, and then we can make some adjustments should we need to. So let's go to our other objects and we'll bring in a cache object. And now we need to be really careful here because we have two cache objects in our scene now. Remember, we have our plastic bag one, and now we have a new cache object which we're going to use to cache our emitter water and also our mesh in a bit. So we need to make sure that this cache doesn't try and recache our plastic bag. So to do that, let's go to the inclusion tab of our new cache, and we have an object list with a mode which is set to exclude by default. So that's great. We can drag in our plastic bag, and it's going to be excluded from this cache. Perfect. So now let's set up our folder. So we'll go to Libraries, MoGraph Countdown, xpSplash, Cache. Okay, excellent. So now let's build cache, and I'll just stay with you here because I'm gonna hit cancel on around frame 70 probably. So it's going to slow down somewhat here, remember, because this is where it's getting really heavy with lots of particles as we kind of keyframed up those parameters to make sure that our volume was filled. So it's going to take a little while, but then it gets to around frame 60 and the sheeter is disabled, and then it'll start caching much more quickly again. So we've got up to 50, 52... Let's just get up to the next kind of couple, and then we'll get an idea of how it's looking. There we go. And that's where we switched off the sheeter. Excellent. So I've hit cancel. All of those frames were cached. And look, if we look down here in the info of the cache object, it says, look, cached frames 70. So it's cached 70. So these first 70 frames are cached. These ones aren't. So let's play that back. But before we do, let's just go to the cache tag and make sure that we put hold on, which means that it won't try and then re-simulate live after frame 70. So let's have a look. Okay. So it's all right. I think arguably it fills up a bit too quickly, doesn't it? At this stage, we may have been a little bit too aggressive with those settings. So let's fix that. We want to have a look at these keyframes in the sheeter. But to do that, let's go to the dope sheet. This is the timeline. And this is going to enable us to move around these keyframes. So let's just twirl down our sheeter. So what do we keyframe? Well, we keyframe both the max hole size and the angle quite aggressively on frame 30. So let's look. If we play through this, you can see it's working well. And as we keyframe those two values up, it really fills up quickly, and it's too quick. So what we could do is, look, let's just move these out a bit, which will make that less of a ramp. Okay, and as a result, we'll need to move these are the disabled keyframes which switch off the sheeter. So we're going to have this active till we get to the end of those two. Otherwise, it might just stop with some holes in. So let's try it at that. So we need to obviously get the cache. Let's just deactivate the cache. So now this is running and calculating it frame by frame. So this is going to be slightly different because obviously we didn't ramp it up as quickly. So I'm hoping that we still get a fill, but it's not as aggressive. And yeah, look, so it's filling up, but we've still got some holes, and it'll gradually get more and more until it gets to, it was around frame 70, I think, wasn't it? So that's definitely better. That's looking great. So let's pause that timeline, go back. So I'm going to reactivate my cache. We will go to build cache, overwrite, and that'll start caching. So I'll pause this now and come back to you when that's complete. So here is our new cache. Let's have a play through, and yeah, that fill is much better now. I'm much happier with that. It's still quick as we want it. We get this, look, we get this nice splash of particles, splash, 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 and then it fills up. That's going to work really well. Now it does develop into a little bit of a hole here at the end, but that isn't going to be a problem because that is something that we will be able to address at the meshing stage. So let's get on with that meshing then. We'll go to generators. Let's go to OpenVDB Mesher. And of course, this requires a source. The source is going to be our emitter water. Let's drag it in. So straight away, it's a little too blobby. And that obviously isn't good enough. But remember, we're going to be looking at our two basic sliders here, the voxel size and the point radius. Let's reduce that point radius down, which is the radius around each particle. Once we get below 3, it'll disappear. That's because we don't have enough voxel information to mesh something that small. So let's just bring this down and it'll bring the mesh back eventually. So I say we could look at maybe 1.5 and a 2 point radius for our particles. So let's have a play through. There's our splash, like these tendrils, and then this starts to fill up. Now, it's a little bit rough, isn't it? You can see the kind of contours of our individual particles, so let's just try smoothing that a little. We've got filters to do that. Let's add a filter, and we'll get rid of our default median. The Gaussian is the smoothest of all of these smoothing filters. It's the most aggressive. Let's just hit that one. You can see how smooth that is. Now at this stage with these holes looks really nice, but if we go back to the beginning of the animation, you'll see that actually we've lost a little bit of the mesh detail because this Gaussian's a bit overly aggressive. Look, these particles have no mesh around them at all. So let's go to that Gaussian filter. We can just reduce that strength down a bit, and look, you can see we're bringing that detail back in. Something like that's fine. So there's our splash, nice tendrils, and it's going to gradually fill up. So what we could do is let's deactivate our the visibility of our water particles. So we've got these nice holes, and then it begins to fill up. Fantastic. Looks really good. Okay, so what we're doing with this, we're not actually going to be rendering and seeing this OpenVDB mesh. What we are going to use it for is we are going to create a bool, a little bit like we did with the 6 fill. But this time, we're going to use our plastic bag as the first object, and the second object we are going to use is going to be our OpenVDB mesher. So let's get this sorted out. We will go to the menu here and let's bring in a bool. Let's bring it to the bottom. So our plastic bag is going, let's make that visible again. Plastic bag is going to be object A, and we actually, let's sort out this bool as well. We don't want high quality, remember we don't need that. And the Boolean type, we want to A intersect B. So let's put that, and then let's drag in our OpenVDB mesh as our object B. So now what you're going to see is where the OpenVDB mesh intersects the bag, it will take on the original topology of that bag, which is really important. Remember, this has to match absolutely exactly. So we can't just rely on the OpenVDB mesh. It's totally different. We have to use the bool to eventually reveal the original plastic bag. So let's play this through. Now, obviously, again, look, this bool is doing an awful lot of calculations here. So even though we have got our plastic bag cached, our OpenVDB mesh isn't cached, but also the bool is having to do all of these very, very complex calculations every frame to kind of work out where all of these OpenVDB polygons are meeting the original geo from our bag. But look, it's looking really nice, isn't it? You can see the effect in question. We have the splash that then becomes the bag. So let's keep playing this through. So what we could do is let's just skip forward a frame, keep going. So we're getting these holes, and then they fill in and fill in and fill in. So we're kind of getting there by 70. Now by 70, we still don't quite have enough volume for these holes to have completely have been closed. And we need that. We need to, at this point, just be revealing this this bag, and we still don't have enough intersection because our OpenVDB mesh isn't big enough. So this is where we can just cheat this and do a very, very fast version to get this fixed. So let's just run this through to a stage where we want it to start filling in more quickly. Maybe about here. Maybe a bit further on. So frame 44, let's go to our OpenVDB mesh. Here you are. And we will go to the General tab. And what we can do, let's put a keyframe on the point radius. And now what we can do is move forward, say, to frame, I don't know, frame 60. And we can start increasing this point radius. And because that's making the OpenVDB mesh bigger, it's automatically intersecting with this bag. So we can go even bigger. And now, look, so at 5, it was virtually there. But look, do you see how the corners haven't formed properly? But if we put it up to 10, now we have our full corners. So let's keyframe that. So we have the splash forming, building up, and at this stage, when we really want this to start closing up, we keyframe that point radius up. Fantastic. So that's looking really good. I'm pleased with that. Let's just run that through. So what we could do is let's just deactivate the bool and the OpenVDB mesher. It'd be handy to cache this at this point, wouldn't it? So let's go to our cache object. And we want to cache this, but we don't want to recache these emitter water particles. We've already done that. So the way we ensure this works is all we need to do is go build cache and then just continue. And if we hit continue, it'll build a new cache for the mesher, but it won't try and recache the water particles. So let's do that. Continue. So I'll pause this cache and come back when this one's finished. Okay, so that cache is finished, and I actually cancelled that cache at around frame 100. So let's just go down to our OpenVDB mesher, go to the cache tag, let's override, and let's just put hold. So when it gets beyond frame 100, it doesn't then try and carry on caching those particles. And at this stage, we can now, because I've cached the OpenVDB mesh, I can switch off the water particles, and now we just have this OpenVDB mesh cached. So that's really good. So what we can do, I haven't got the bool switched on because obviously it's quite slow, but we can work out if our OpenVDB mesher is big enough to completely intersect to make our plastic bag by having the bag visible and the mesh visible. So this is the bag. Here comes the OpenVDB mesh, and anywhere where you can see the original bag, that will be a hole because it's not being intersected by the OpenVDB mesh. So at the moment, we've still got holes, which is nice, but then it fills in. And now, because you see how we animated that VDB mesh up like this, that ensures that it completely encapsulates our bag. So that's really handy. So now if we reactivate the bool, hit play, we get the OpenVDB explosion. It then intersects with the bag, which gives us the original geometry, and this is going to be working perfectly. So the last thing we need to do is we need to explore animating the plastic bag. Because remember, this plastic bag has got our animated keyframes on. We just kind of disabled them temporarily. So let's go back. Let's switch the bool off. Oops, let's widen that out. Let's switch the bool off. Let's go to our plastic bag cache tag. Let's go back to play per frame, where we had all of our keyframes. So now we have the animation back. So what we can do at this point is, Now this actually might have unearthed a problem which we may have to rectify. Now we have the animation back. Can you see that we have a section that now isn't intersecting the bag? So let's go around to the other side. And I mean, the back face isn't important because we're not actually going to be seeing that, so that doesn't matter. But this one could cause us problems because we could lose some of that geometry. So that was very lucky that we did that before we did any more caching. So let's fix it. We need this OpenVDB mesher to be bigger. So let's go back to frame 60 where we animated our point radius up, and let's put that higher. Let's put that up to 20, which is even bigger. But of course it's cached, so we're not going to see that. So let's switch off the cache. Okay. And switch back on our water particles, because then there is something obviously to cache. So that's much bigger now. Excellent. So let's play this through. So it's filling up, it's intersecting, the holes are gradually slowing. And we want to see that when this OpenVDB gets to its final point, it completely encapsulates. Yeah, so we've got it now. Excellent. So we did need that. That was very good that we did it, and we spied that early. Excellent. So what do we need to do? Let's re-cache the OpenVDB mesh. So we will enable cache. We'll go to the cache object in question. Let's build cache. And well, actually, we want to overwrite this, but we don't want to overwrite our emitter. There's no point in caching those particles again. So let's just cancel that. The easiest way of doing this would be, let's just delete the cache tag on the OpenVDB mesh, as there's now no longer a cache tag there. Let's go to cache. So now we can build cache, continue, which will make a new cache for the mesh, but it won't recache the particles. So continue. So I'll stop this again at around frame 100. So I'll pause it now and come back. All right, so we stopped that on frame 107. So let's go back to my OpenVDB mesher. Let's override and hold so it stays on that. So now let's have a look what we've got. There we go. Excellent. So we just need to offset this animation a little bit because the animation of our bag is starting too quickly. We want it to kind of start animating maybe about, well, we've got some holes in, so maybe around that frame 37. So let's go to our plastic bag cache tag, and here are our animation keyframes. So we can just select those and let's move them up so it starts animating here when we've got these holes, maybe something like that. So let's have a look. So now we've got the splash, and then it'll start to crease in. So we can only really see the effect of this if we activate our bool. And again, this isn't the fastest operation. The bool isn't particularly quick, but it's necessary for our topology, and it's going to work well for us. So let's just hit ND so we can see those nice lines forming. So here's the splash. And it's looking good. I really like the kind of splash tendrils that we've got in there. And that's going to look really nice when we've got our kind of transparent dispersive material on there. It's going to look really cool, and it's gradually filling up. The nice thing here is that this is going to start deforming into our bag shape before the holes are filled up, and that's kind of what we want. It's going to be a really interesting look. So we can see it's going to start creasing in. Here's the creases coming. Look, this is looking good. Now, obviously, this is on our low resolution mesh, so we sort out these shading issues. But there, look, we're getting this nice folding. And then it's down to our original base mesh. Good. So I think arguably it happens a little bit. We've got a few too many holes. Let's just actually deactivate those water particles. I think we're getting a little bit too much of a crease here before it's really forming. So let's just move these keyframes just out a little bit, And then let's start that again. Let's see how this looks. So it's very difficult at this, obviously at this frames per second in the viewport to get a real idea of what this animation feels like. So once we've kind of got an approximation of what we're happy with, what we'll do is we'll bake this down. Now this is a bool object, so it can't be cached with an xParticles cache object, but we can export this as an alembic, which is going to bake this down into one file. And once that's done, it will run pretty much in real time. So then we can get an idea about the animation, and then if we need to make tweaks, we can, and then re-export it with those new settings. So that's looking pretty good. Instead of watching this chug through the entire thing, let's get that alembic sorted, and then we'll make adjustments should we need to after viewing that. So the way in which we do that is, well, first of all, we need to do something. Now remember, the shading was looking a bit ropey, wasn't it? And that's because our bool is actually just using our original plastic bag, which hasn't got fine topology. But remember, we placed that plastic bag in a subdivision surface to make it look much more detailed. So we're going to have to do that now. Here is our subdivision surface that we brought in. So let's make the subdivision surface a child of the bool, the plastic bag a child of that. And this means that we're going to get, look, if I make that visible again, this means the bool is going to be doing the calculations with our finer mesh, and it's going to look spot on. It'll run more slowly now as a result, but it is going to work with that. So now, look, you can see it's looking much more detailed. It's looking really great, actually. So let's bake this down. So what we need to do, we can't actually export just the bool as an alembic, because what will happen is it'll make the child objects separate alembic files, and the bool operation isn't going to work. So we need to connect it together. So we'll go to this menu and bring in a connect. Let's bring it down here and make the bool a child of the connect. And the connect is what we're going to export. So let's right click, and we can just hit bake as alembic. Now, I'll pause this and come back to you when it's finished, because this is going to take a while. There's an awful lot of polygon information that the bool is having to deal with here. So I'll pause it and I'll come back to you in a bit. All right, so that took about 3 minutes to export. And what happens is you get your alembic object automatically brought into the scene for you, and it obviously carries the same name as the object in which you exported. So let's just deactivate everything under that connect and make it all invisible. And now we just have this cached alembic. So, I mean, look, we can switch absolutely everything off. None of it needs to be active now, because we can literally just have this one alembic object, which is going to be our shrink wrap. Now, one thing with alembics is a bit of a quirk of the export is that on frame 0, you kind of get a representation of what the object was like when you hit export. And then if we go look forward to the first frame, then suddenly we get our proper start of our splash from our bool operation as expected. So a couple of different ways of getting around that, but the easiest way is just to go to the connect to our alembic, and we will just, on the first frame, let's disable it. And on the second frame, on frame 1, let's enable it, and then we've got what we expect. So there we go, and it's looking fantastic. Really pleased with that, and we got a really nice animation. So as you can see, we've got these nice bubbles. We've got a little bit of deforming going on here before the bubbles close, then the bubbles close, and then zoom, it comes down onto our 5. And I'm really happy with that. And the beauty with an alembic is very similar to our xParticles cache objects, is that we can offset the timing, we can increase or decrease the speed of playback, we can use frame by frame retiming, just like we did in the cache tag. So we've got loads of flexibility now that we have this cached. And that's looking great. So we're going to have our 6 fill up. When it gets to the top, and the 6 becomes almost like a glass solid, then poof, it explodes out into our bag and then shrinks down to this stage. And that's looking really good. So next, what we need to do is animate our mixed fluids, which will be mixing in a kind of a gooey, like wobbly way inside of the number 5 volume, which is living inside this shrink wrap bag. Excellent. Very happy with that. So let's incrementally save that one so we're all ready to go, and then we can move on to the next part.